Hey guys, welcome to Code Decode. In this video, we are going to look into some Maven interview questions and answers. This is going to be a very intense topic where we are going to start with very small what is Maven, what is POM, why is it needed, and we will go as deep at what is the Maven life cycles. And if we have a project, we have added a new dependency or we're starting a new project, when to do Maven clean, when to do Maven install, and when to do Maven update. All these things we're going to cover end to end rigorously into these videos. So let's get started and let's see firstly what is Maven. So Maven is an open source build tool developed by Apache Group for the Java projects, for managing the Java projects. And they basically manages the entire life cycle of the project, including compiling, testing, packaging, and managing the dependencies. Too much of theory. Let's quickly go first and let's see into the Maven. So this is a Maven project that we have created. So here you can see this is the life cycle of the uh, Maven goals. These are basically the goals of the life cycle. And what it does is, whenever you write a code, the task of Maven is to basically build the whole project into and its life cycle. So basically, it compiles your code, it tests your code, it packages it into jar or war, whatever you define here. By default one, it is jar. Since it is not defined here, it will be the by default one as jar. But if you want it as a war, you can explicitly define that also here. And at the end, install all the dependencies, new dependencies that you add, and then you also deploy it to the repository wherever it is needed. So this is basically a build tool. Now first let's understand what is a build tool, and then we will come back to what is Maven. So a build tool is a software framework which is used to automate the process of generating the source code, compiling it, running it, packaging it, and then deploying it. So in short, it does the following task: generate the source code, compiles the source code. How does it do? It compiles the source code. It runs the test cases. It also runs the integration test cases if possible. It packages the application into jars and war. So it's packaging, it's installation. Installing is basically to manage the dependencies. And then at the installed code, which is packaged, is then deployed to the various repositories like local repository, server repository, central repository. In the upcoming questions, we'll see how many type of repositories we have and what is the difference between them. So that is a build tool. Basically, it is used to automatically build your project. You don't have to explicitly go compile your code. You don't explicitly go and run your test cases. You don't have to package it. You don't have to manage all your dependencies by doing the right click, add the jar to the build path. You don't have to do that. That's what Maven does for you.
Hey guys, recently we have launched a course covering an end-to-end full-stack application using Angular as front-end and microservices and Spring Boot as the back-end. Also, we have used Cloud to deploy this application, and we have used CI/CD, that is Jenkins and Argo CD, for continuous integration and continuous deployment. The technologies that we have used is REST-RESTful web services, Spring Boot and microservices for back-end, Angular for front-end. GitHub we have used for version control system. Also, to make the code unit testable, we have used JUnits. We have used Sonar for code quality checks. Also, for containerization, we have used Docker and Kubernetes. And to deploy this whole application, we have used AWS and multiple services from AWS. Also, we have used SQL as well as NoSQL, that is MongoDB and SQL. On AWS, since for the SQL we have RDS, we have used those services, and Jenkins and Argo CD for CI/CD pipeline. Also, this is an architecture of the application that we have created where the front end is Angular and the back end is microservices. We have used ALB load balancers, Ingress for routing and load balancing. And we have used SQL and MongoDB for SQL and NoSQL DB management with Eureka server and all those microservices counterparts. Now, this is the CI/CD pipeline. This is the CI/CD flowchart for the application that we have created on local. So this is something, a flow when you create an application in local, push it to GitHub, create a Jenkins pipeline, and do the CI/CD using Jenkins and Argo CD. And at the end, deploy the whole code at AWS EKS. Complete description of this course is covered in a very separate video. The link for that video is also given in the description bar below. And also the link to purchase that course from Udemy is also in the description bar below. So please go and check the description for all these links.
So what are the benefits of using the Maven, Apache Maven? It is basically used to manage all your processes such as building, compiling, releasing, documentation. Also, reporting is also one of the important part of Maven. We will be seeing the reporting part also in the build life cycles we have here. That comes under the site life cycle in the Maven. I know this looks very complicated. Let's remove this completely out of your site. And when we will be coming to that point, it will become very easy for you. Trust me. So let's start very slow and then we will go to that deep level. So the Maven is basically used for managing your project, simplifying your build process. It builds your project, increases the performance of the build process because it is automated. It also automates the dependency management. Basically, it automatically downloads all the jars, words that you define in your pom.xml. We will be seeing what is pom.xml. And it automatically does it from the Maven central or the repository that you give in the URL there. It will automatically do that. You don't have to explicitly do it. It also handles your project information. Too much of theory. Where is the project information? I don't know that. So this is where is the project information given. This is where you have the name of your project. This is where you have description of the project. This is where you have URLs, and all those things also are present in your Maven form. It also maintains your cross environment consistency. Basically, when you write a Maven project, since you have a proper pom.xml, you don't have to worry about your dependencies and processes. It is all well defined in your pom, and it will be done only in this particular manner only. First, it will validate, then compile, then test, then package, then verify, then only install, and then only deploy. So everything is very much consistent when it comes to the Maven. The last one is easy dependency addition. You can just go add your dependencies to your pom.xml. Just do the Maven install. The latest dependencies will be installed from the remote repository or central Maven repository and will be added to your own local repository, that is M2 folder. So it basically heavily relies upon pom.xml to define your project setting, dependencies, and build instructions. So that was all about the Maven we have. Now, what is the difference between Ant and Maven? If you have not worked with Ant, you can directly skip this question saying that I never worked on Ant. But if you are old enough like me that you might have worked with Ant initially, then you must know what is the difference between both of them. Ant was, yes, the legacy one. Maven for me is just much more modernized and much more easily setupable also, and workable also. So difference between Ant and Maven will be the both of them are build tools first of all. But Ant is a general purpose build tool. This is a automated build tool. Also helps in project management to us. Also, it depends upon build.xml heavily to define its task, while we have pom.xml here, where we have everything defined in an XSD. I'll show what is XSD here. Just for the quick notation, what I'm going to show you here is this is where the XSD lies. The next approach comes is that this is task oriented. It is step-by-step instruction, while this is convention over configuration. The fourth difference will be the dependency management. So basically, Ant does not provide us any dependency management, but we do have a built-in dependency management using the dependency management tag, also using the BOM, that is bill of management. We'll be seeing both of them in the video later on. The next is the project structure. There is no info structure, while there is a standardized directory structure that is also given with this XSD that I'm going to show you in a minute. There is a flexibility. Yes, it is highly customizable, while when we have the very limited customization options with Maven, but we do have an easier setup with Maven. Also, the learning curve is very steeper, and this is something I also felt when it comes to the Ant. But it is much more easier and very straightforward for the Java projects when it comes to Maven. So that was the overall difference between Ant and Maven. Answer this only if you have worked with Ant. Do not try to answer this if you have not worked, because they might twist and turn you with the questions in the Ant. The next is what is POM. Now this is where the important question starts with the Maven interview questions. We understand it is a build tool, but for building and doing all the configurations, we have one proper project object model called as pom.xml, which is a configuration file in Maven. We here saw that this, right? We have the pom.xml, we have the build.xml here. For this pom.xml, we have all the project related details, like what is your project name, what is your project version, what is the group ID, what is the artifact ID, what is the version, what does the snapshot means, it is work in progress. Just an FYI. What is the name of your project? What is the description of your project? What is the URL for your project? All those project related details exist in the pom.xml. We have dependencies here. If you can see here, we have dependencies also here. We have plugins. So if you can go down there, we have multiple builds also there, plugins also there. We have repositories also there. We are going to cover each and every of them in very much detail in this upcoming section. So what is included in pom.xml? So the basic structure of pom.xml starts with a parent tag called as project. This project is the root element for the POM XML file, and it has three attributes importantly, that is XML-NS, XSI, and XSI schema location. Now, XML-NS, as the name suggests, is an XML namespace. Namespace is actually a way to link your complete pom.xml to a Maven's pom.xml standardizations. So this is Maven's POM standardization. Why is it important? Because it defines the structure and rules for the XML document for your pom.xml, which is an XML document again, based on the Maven specification. So Maven have given you some rules and validations. Until unless Maven and XML parser are not able to validate your POM, it is not going to build your project if it is a Maven project. So this makes sure that you are writing a proper correct pom.xml with proper elements, attributes, and make sure that you have a valid structure for your pom.xml so that your build is not erroneous or error prone. Now, XML-NS attribute ensures that your pom.xml follows the Maven schema, enabling the correct validation, correct building process, and supporting tools. Without it, the file may not be able to process correctly, leading to the build errors and lack of validations. The second important part is XSI. This XSI stands for XML schema instance. This is also a way to specify which XML instance is going to be used. Now, this XML instance consists of the important part, that is schema location. All the XML-NS XSI contains multiple attributes. One of the attributes of XSI is schema location. This schema location actually tells you where your XSD lies. So if I'm going to copy this XSD and copy it and then paste it here, and I'm going to show you what this XSD consists of. So this is basically the entire description of how your POM should look like. So it says that the element project is type of model, that is project object model. It has a description which gives the root description element. We have model, we have multiple parents, we have group ID, we have artifact ID. So where do you think we have group ID, artifact ID? We have used here group ID, artifact ID, version. So this group ID, artifact ID, version, these tags are actually defined here as an element. If any element which is not defined here and you are trying to use in your project object model, it will throw you a error. It will basically, you will not be able to build your project. You will not be able to compile it also. So that is the reason this XSD is very important. This XSD is going to give you each and every element which is allowed into your POM. Also, what it does is also here in the description. So group ID is a unique identifier for a project. Usually it is a fully qualified package name to distinguish it with the other projects. For example, I am Code Decode. So I want my project name should be Code Decode Kafka Producer. So this becomes the artifact ID. We are going to, group ID. And to uniquely identify this, we have a different, so the producer can have a demo, it can have a configuration. So I can have multiple projects under the same scheme of Code Decode Kafka Producer. A producer, I can show you demonstrate. So this is demo. I can show you some configurations. So it will be Code Decode Kafka Producer configuration project. So that project specific unique name becomes the artifact ID. We are going to cover each and every of this in the next few minutes. But here understand that this is how the elements are described here in this XSD, and that is why this XSD is very much important. So this provides the location for your XSD for project version 4.0.0, enabling Maven to validate the structure and ensures that it conforms to the POM model. Anything which is not there will give you a validation error, and you have to make sure that you have correct pom.xml with the correct elements. The next very important thing is a model version. If this much is clear, we have the project, which is the root or the parent element. It has three attributes: XML-NS, XSI, and XSI schema location, where the XSD is present, where you can see what all elements is allowed in your POM. The next important thing comes is the model version. What is this model version? This model version specifies the version of POM model being used. So here in the XSD, you can see this is 4.0.0. This is the model. So if you can see, this is the model, and this is 3.0.0. That means this is compatible with 4.0.0. So this is the specific POM version that you are using for validating your own POM that you're creating. Its typical value is 4.0.0. It tells the Maven which rule and structure to apply to this particular POM. If I make it as 2.0 point something, then here all the rules that is defined in the 2.0.0 version of your Maven Apache POM will be valid here. But since it is not available right now, only 4.0.0 is the typical value available. The Maven expects this value in every POM.file. If it is absent, it will not be able to recognize as a valid POM. It may throw an error and stop the building process. And the typical value defaults to 4.0.0, so you can omit this if you want a simpler POM, because that is the only available model version in this particular pom.xml file. So that is why this is important. The next is the group ID. So here you can see, okay, I'm going to cover this parent. This parent is a way to define your parent, which is where all the versions will be defined, and hence you will not be necessitizing the version tag here because you have given a parent tag for the Spring Boot starter. So all the compatible versions will be fetched from here only for all your web, Kafka, everything. For all the Spring based childs, that version will be referenced from the parent tag only. So if that is clear, let's go to the group ID. This group ID, as I've already told you, is the reverse domain name. So my URL or the domain name can be codedecode.com. So in the reverse order, it can be decodecode.com. But here for the simplicity, I've written as com, code, decode, Kafka, and producer. This is basically a unique way to identify multiple projects in a particular repository. Now, this particular repository or the group of projects can have multiple different projects. So I can have demo, I can have configuration project, which is having only configurations for my Kafka producers. So this particular artifact ID uniquely identifies each project into that particular group. So group ID is a unique identifier for project group or the organization. It uses the reverse domain name like com.example. So it can be example.com. That is the domain name. It can be in the opposite direction also. So this is one of the part of projects coordinate in Maven, which uniquely identifies the projects across all Maven projects. If group ID is missing, the Maven cannot uniquely identify the project, leading to the dependency resolution error. So this is also a compulsory thing. If I try to comment this, you will get an error. So if you can see, we have an error that group ID is, so we get an error, group ID is important. Going forward, the artifact ID, a unique artifact ID is important for a group ID, and that is typically the project name. For example, this is the demo for my producer. The purpose is to specify the name of the project combined with the group ID together becomes the unique identification of multiple projects across the whole organization. The next is version. The version specifies the specific version. If anything that is ending with snapshot, that signifies that it is development still in progress. And if it is 1.0 or 2.0, that means it is a specific release version. For example, here the starter parent is 3.3.4. That means it is not a in development release, but it is a stable version. But when I come to my own producer demo project, this is 0.0.1 snapshot. That means it is work in progress or development is still in progress. It's not a final version. The release version represents the stable releases, while the snapshot version represents the development versions that are frequently updated and are mutable. That is not something which is going to be there for a long without getting a change. If the parent POM is there, you can omit this version if it is defined in the parent. So this version is very important when it comes to the starter parent. This will decide all the dependency versions also. You don't have to explicitly define it here. Now the core component starts from here after this all ends. That is a project information. So the name of the project, that is the producer project. The description, what is this? This is a demo project for Kafka producer in Spring Boot. Then you have a URL. So this is something which defines the metadata about project, and this is explicitly not a configuration related which is changeable. It's rather some information about your own project. The second comes the properties. For example, here you can see this properties, right? This properties is the custom properties that you can reuse across your pom.xml. For example, I'm going to use Java version as 17. Now, I'm also stating that my Spring Boot version should be 3.3.4. So, I can add this tag also here, like a Spring Boot version 3.3.4, I can directly use this version here as version and utilize this particular name of property or the custom property and reuse it again and again. The benefit I'm going to get is that if I'm going to change anything, I just have to change it at one place. All the other dependencies who are going to use this version will automatically take the latest value from this properties tag. So custom properties you can reuse through a pom.xml that comes in the properties tag, often used for versioning your dependencies or setting the plugin parameters. The properties defined here can be referenced anywhere else in the POM using this $property name. So if you want to use the Java version, you can use $java.version and it will be coming as 17 across all. And this makes it easy for upgradation. If you want to change it to 1.8 or 8, then you can just do it at one place. And all the other properties, dependencies which are using this property will have the updated value. Now, the third important part comes as dependencies. This tag is very important. Now, we have to make sure that we understand this clearly. Now, dependencies is the parent tag. Under this, we have multiple dependency, which is basically nothing but a set of jars which are required by a project to build and successfully compile and run and deploy. So, these are the dependencies, which is a set of jars which are added as a list of libraries and external dependencies that project needs to compile and run. Each dependency includes at least the group ID, artifact ID, version, which is not that compulsory. The group ID is actually the organization name, the artifact ID is the project name. This uniquely identify each project in the Maven Central also. Since you define it here, if it is not present in a local M2 folder, it will be fetched from your Maven Central repository. The version is not compulsory for this Kafka, Spring Boot Spring framework. Reason being, we have used the parent here. The version will be fetched from here. The next compatible and the latest version will be fetched automatically, and hence it is an automatically dependency management tool that is the Maven for us. Also, we have scope. So here you can see this is how you define your scope. With the group ID, version, artifact ID, you can define the scope also. This is the default scope, that is a compiled scope. So if not specified, the default scope is compiled. You can omit this unless you want to specify the specific scope. For example, test. Now, if I have some J units, I don't want this dependency in jars to be added in all the phases of my development. Also, I just need it for testing purpose, and I can specify the scope is only for test because I need these many jars. Suppose it has hundreds of jars internally. I need all of those packaged jars only for my testing purpose. Then don't add it during the compilation phase, because during compilation I don't run my test cases. Also, you can exclude your dependencies. For example, I have my common slang dependency, but I don't want commons collection for dependency here. So this is how you can use your exclusions in your particular dependency. So in the dependency, you define your group ID, artifact ID, which uniquely defines your particular project. You also defines a version, but you also defines the exclusions that ignore this, exclude a specific transitive dependency. I don't want this to be added when all these jars will be added. So that particular jar will be excluded from this particular dependency, set of jars. Now, if that much is clear, what we don't have here is a dependency management tool. Now, this dependency management tag allows you to define the versions of dependency in one place, allowing you to specify dependencies later without repeating the version. Too much of theory, let's understand with the code. Now here we have all these things that I have already discussed. Now this is a dependency management tag we have. Here also what you can see is a replica of these dependencies, parent and multiple dependencies. So here we have dependencies as a parent and then we have multiple dependencies here. Now, why do we have dependencies again in dependency management? So remember, dependency management does not say that add these jars to my build path. They don't do that. It just defines that manage my dependency with these versions. So if you have the Spring Core dependency in your library or the build path, please have the version 5.3.10, otherwise it will not compile that properly. Way to not to add dependency directly to a project, but just provide a version definition that can be referenced later in the same project or in the child project, then use the dependency management. This is basically not to add the dependency. These dependencies tag that you have seen here was to add the dependency. If you build this with a Maven, these dependencies are actually going to get downloaded from the Maven central and get downloaded into your local. But if you have defined these dependencies in your dependency management tag, then it will not actually be included in your M2 folder. Rather, it just says that in case in future, if you are going to have the core jar, just make sure that you have this compatible version, because this version has those changes which I need to run my project. As simple as that. Okay. So a parent POM with a proper dependency management section will make sure that all your child will have these particular versions available for them. So child modules can include these dependencies in their own POM without specifying the version. So remember, here since we have the starter parent defined, that is the reason we have ignored the versions. But also in the starter parent, there must be a dependency management tag. If there, then it will also make sure that the child has that particular dependency version only that is defined in the dependency management of the parent POM. Now, when you can use this dependency management only and only if you have a multiple module project and you are having the parent POM with you. Now you want to make sure that all your childs use the same version, and you want to make sure that there is no version conflict in your multiple childs when they are interacting with each other or when they are interacting with the parent. Then you make sure that using this dependency management tag. This enforces the version that you have in your M2, but that doesn't make sure that it is downloaded in your M2. Now, how will child reference it? So I have my parent named as com example parent POM, and this has my dependency management for Spring Core. In the child, I can directly add the Spring Core without thinking about adding the version here, because I have the parent tag here, and the parent says com example parent project, and this is same as com example parent project. So here I have defined my project name. Here I'm defining this as my parent, and hence anything which is defined in dependency management tag, all the versions will be fetched from here only in my child. I don't have to explicitly add the version here until and unless I don't want to explicitly force it to use another version. So it gives you a flexibility to not to define the version, but it also gives you the customization facility that if you want to really override it, you can override it here. So if the child module requires a different version for the specific dependency, it can specify this version explicitly. This allows you to have this flexibility, still benefiting from the centralized management for all the other dependencies that is defined in the parent using the dependency management. So that was the beauty of dependency management tag. Just don't get confused if you see any such dependencies getting repeated in your dependencies tag also and your dependency management tag also. Interviewer will trick you saying that I have the Spring Web here also, I have Spring Web there also. What is the use of having it twice? So you can say that if this is my parent POM, this is the dependency management dependency which is not going to download in my M2. Rather, it is just going to, in the dependency management, it is just going to give the version consistency across all my multi-module childs and my own project. That's all the dependency management do. It manages you. It does not include that. Now, what is the benefit of using dependency management? It ensures that all modules are using the same version, so there is no compatibility issue. It reduces the number of lines because you don't have to explicitly define the versions here in all your children. It also have the ease of update. You change at one place, that is in parent. All the child started using the updated version. You don't have to do anything. Also helps in conflict resolution, because if multiple different modules interact with each other, have the different versions of the same library, you will get into the trouble. So that is why conflict resolution is also done beautifully with the multi-module or the multi-hierarchical project where you have parent and multiple children. The next important part is this build tag. Now this build tag configures the build setting. So this is the very important tag which actually runs when Maven builds. So there is a life cycle called as Maven build. During that build, these plugins will be fetched and will be used for your building purpose. So it configures your build structure. Basically, your compiler settings goes here, your directory structure goes here, your source code goes here. Everything and anything that the Maven as a build tool needs will be configured in the build section. So this section is very important. Now the below build section is a standard configuration to compile a Java code. I'll give you the code first, okay? This is the build tag we have usually. Here it defines where is the source directory. Usually by default it is src main Java. You don't have to explicitly denote it. As you can see, I don't have it, but still my code runs successfully because the basic source directory is src main Java. If it is different, then you can explain here that this is my source directory. You have to take the code from here, compile it into bytecodes, run it into exe codes, and do all those things with this particular source directory. So the build tag is responsible for denoting the compiler setting, the directory structure setting, and the plugins. It specifies where the source code is located using the source directory. Then it also promotes maintainability, flexibility, allowing you to change the Java version in one place rather than going through all of it. So here is where you have your Java versions getting. If you remember, we have java.version defined here, right? In the properties, java.version. Now you're reusing it here like this. And that is why I say this property tag is very important. This is how you just add it at once. You don't have to write 17 here, 17 here. And if you move to Java 8, then you have to change 8 here, 8 here. You don't have to do that. You just change it to the property tag and then it is reusable and dynamically used everywhere. The second section is this plugin section. This plugin section is where you decide that this build is going to be done with which plugin. Now this plugin is the one who is going to compile your source code that is in src main Java into the bytecodes. And the version is going to be used like this. So if you use the parent form, you may omit this. The configuration can also be omitted if you don't have to tell them which source and which target you have to do. But this configuration helps you define what is your source conversion and what is your target Java version conversion. I'll tell you what it is. This plugin is the element that defines a specific plugin to be used during the build process. The source that you can see here, that is 17 right now, specifies the version of Java source code. So you are creating some Java code, okay? Now that is with Java 17. Now it does not support Java 23. So if there is any code which is written with Java 23 enabled features, then it will give you a compilation error at the compile time only. So how do you make sure that all your code should be Java 17 only? That is done by giving the source that I just should have all the features used with Java 17 only, nothing from Java 23. Similarly, the target specifies the version of the bytecode to be produced by the compiler. This target is going to make sure that your bytecodes are compatible with Java 17, and any of the person who is going to have this machine independent bytecode can run this bytecode with Java 17 in their system. So that's the beauty of source and target here. This section is executed as a part of build lifecycle. Important part to note that we have multiple build cycles. We have multiple lifecycle events, but during the build lifecycle, this build tag will be run. Here, the Maven compiler is not only included here, but also configured to compile your source code into Java 1.8 when the build is actually running. The next part is this repository. You might not see it in most of the pom.xml, but this specifies the repository for Maven to search for dependencies other than the default Maven central repository. So we have Maven central repository, something like this, mavenrepository.com. If there are some of those repositories which are not available into that mavenrepository.com, then you can explicitly define your own custom repository. This happens in multiple enterprise level applications where you have a different repository. Then you can add the ID and URL here, and it will going to fetch all your dependencies from this repository rather than your own Maven central repository, which is not that safe enough. So if all the required dependencies are not available in Maven central, then go for this. If it is already available, then this section can be easily omitted. The seventh one is plugin management. Now this is very important. You will ask me that Maven compiler was already defined during the build. Here we have defined the Maven plugin. So remember, the plugin management tool is something very similar to the dependency management tag. This will not going to get the compiler plugin anywhere from your repository. It is just going to maintain the version for you. So this is not the place where the compiler is going to run or build your project. Java project. It is just going to maintain the version. So it defines the default version for configurations of a plugin, which can be used throughout your build without redefining the details. This section is only to manage the versions in your multi-module project also. It does not actually executes the build at that particular point of time. So this plugin management section, you are telling Maven that which version of plugin you should use. But what you are not doing is that you are not actually executing them. You are not actually building it. The build will happen in the build tag only. Plugin management only manages your version, something very similar to dependency management. Now we have also called something called as profiles. Now if we have multiple profiles, different environments, then you can use profile tag also. I'll give you the example how you can use this profiles here. I will not suggest this because I suggest using profiling as the application.dev.profile .properties or .yaml. Basically externalized configurations is what I suggest. I don't always appreciate using these profiles in your pom.xml. But if it is really necessary, you can use it here and you can activate anything by default. Here the development environment is activated by default and you can have your dependencies. Now I'll tell you one reason why this is sometimes used in the project. Suppose I have one JPA repository or we have some ORM framework that is getting being used. Now the version of that is different in dev environment and in prod environment. Then you can have your specific versions in the development and the specific different version in your production. So that is how you manage your different properties of your different dependencies in your different profiles like prod, dev and all. So this is where you have different environments. So switching between them is important. You can adjust the features, you can adjust your libraries, you can adjust your versions here. You can also have few default activations, like for example, I have dev profile being default by active. Also, you can have your prod enabled using the env variable, and this env will be enabled with setting it as -d env equals to prod. If you do -d env equals to prod, then by default, this env will have prod value. If it is prod value, then this will be activated because it is under the activation tag. And if it is activated, then a specific different version of Spring Web will be added to your dependencies by the dependency management tool that is Maven for you. So that is how you can manage multiple different versions of the dependencies if you are having multiple different environments. But if you have just the properties to be added, you can go for the customizations using the properties file. If you have different versions of the same library to be used in different environments, then you can use profiling like this in your pom.xml. Usually this is not the case. We always try to keep the similarity so that nothing breaks in the prod if it is not breaking in the dev also. Now we have plugin repositories also. Since we have the three types of repository, the local repository, central repository, and the Maven repository for your dependencies. Similarly, plugins have also to be installed in your project, right? So for that also we have plugin repository. I'll give you one example. This is the plugin repositories. This is one of the URL for plugin repository. This is another URL for the another plugin repository. Now these plugin repositories will have plugins in them. So this plugin repositories used to define the external repositories that Maven can check for plugin if they are not available with the central repository. So plugins are just the addition functionality during the build, such as compiling your code, you need Maven compiler or Maven compiler plugin. Running your code, you might need some JUnit plugins. For that reason, we have some different plugin repositories. Also, an important thing to note is you can mention multiple plugin repositories, but also you can have the two things, the snapshot versions and the release versions. If the snapshot is enabled, then you can also have the plugins which are still in progress installed in your plugins. But if it is false, then you are ignoring the snapshot versions. If the release versions are enabled, then only the release versions of the plugins will be installed and the vice versa. So basically, if the snapshot is true, your release will be false. Your snapshot is false, your release will be true. Again, snapshot is the work in progress. The releases are which are already in stable conditions. So this is how you have to make sure that your plugin repositories are also enabled. If your plugins are not available in your Maven Central, like this in the Maven repository, then you can install the plugins from different repositories and then you can directly use them like this in the plugin section, in the build section. The last one is the reporting. This is also many times you might not find it, but in the upcoming video, if I'm going to discuss about the Maven lifecycle, the third one is a site lifecycle. This site is the one which is responsible for generating the documentation and reports, which is very important for a enterprise level projects. You just cannot live without the reports and documentation for your project. And it includes the surefire reports, the JUnit reports, your documentations, and all those things. So to run the reporting that is done in your pom.xml, you can run the MVN site. Now the example of this reporting tag will look like this. This is the reporting tag. This is the plugins. So you have multiple plugin here. And you can define that this reporting tool plugin will be used for generating the reports. Now how and where this report will be generated? So this report will be generated to the target/site. So for example, I have my home, I have user, this is my project name, this is the target folder. All the projects will have this target folder, right? So here there will be a surefire reports. You can also have the site folder here, and then you can have your surefire reports HTML. One last important component is this multi-module tag. This tag denotes if you have a multi-module project, then you can have multiple modules like this. The last one is the parent POM, which we have already discussed, where we can include the parent project like this with a proper version, and all the dependencies will be included into the child with this particular version. We don't have to explicitly define the versions for this. So this is something we have already covered, the parent dependency, how we can add that. Apart from this, we have many things to be covered. That is, what are the build life cycles? For example, clean, default ones, and the site ones. The default one includes clean, build, install. So this is how we have to cover what is the clean, build, and install one, and deploy. Also, when to do Maven clean, when to do Maven update, and when to do Maven install. What are the difference between three, and how is Maven update only and only specific to ID? It's not something related to a Maven life cycle. What is bill of management material, and all of these things we have to cover. If you want another video, let me know in the comment section. I'll create another video for all of these content also. Thank you.